All right, this is a review of section 5.6 and 5.7. So really important, we're dealing with linear inequalities. One of the examples is you have a single linear inequality. And then the other example is when you have a system, meaning you have two linear inequalities and you want to see where do they intersect. So we're going to start with the single linear inequality. The two forms that you're going to get it in, you're either going to get it in slope intercept form, which is y equals, this will be an inequality, so it won't be equal, but it'll be the format or the template y equals mx plus b, where b represents your first point, your y-intercept, and m is your slope, which helps you find the next point. So very important, this is your y-intercept, it's your first point. And then once you plot that point, you're going to utilize the slope to find the next point. And once you find 2 points, you can draw a line. So in this equation, this one, y is greater than 1/2 x plus 4, we see that our y-intercept is 4. It's going to cross the y-axis at 4. So we go on the y-axis where 4 is. That's our first point. And now we're going to take the slope. The slope in this example is going to be 1/2. So when the slope is 1/2, if our slope is 1/2, remember, it is rise over run. So it's either going to go up or down, and then it's going to either go right or left. So up when it's plus a number, down when it's negative a number, right when it's plus a number in the denominator, left when it's negative in the denominator. So since we have a +1 over +2, that means we're going to go up 1 and then right 2 from this y-intercept. So from this point, we're going to go up 1, right 2. We can do it again. We can keep repeating it, and then we have a linear equation. Now, we notice it's not an equation. Oh, I got some stuff here. Whoa, Mr. Maxey, everybody makes mistakes. I forgot to pay attention to my inequality. That is a greater than sign. So very important, when my inequality is a greater than or a less than, I'm going to have open circles. I'm going to have an open circle, and I'm going to have a dotted line. Dotted line. And what that means is, because we're not including the border. The border between my true and false, that's what we're going to graph here, is not including. So we are not including the border. The border is going to be false. All right, those would give us false values. If I had a greater than or equal to or a less than or equal to, I'm going to have a closed circle for my points, and I'm going to have a solid line. We can do little arrows there so we know that that's the line. And the reason why they're closed circle is because we are including the border, because the border are true. Those are solutions. So in this example, it's greater than. So I needed actually open circles there. I need an open circle, an open circle, an open circle. And more importantly, I needed, or just as important, I needed a dotted line. So now this is a better representation of the border. The border between, as I used to say, California in Nevada, okay? And so I want to find where is the true side. Where are the solutions? I know the solutions are not on the border, but one of these sides is going to be the solution. Either this side or this side is going to be the solutions. So what I do is I test a point. I'm going to test this point 0, 0. So 0, 0. The reason why I pick 0, 0 is because it's easy to plug in these numbers for x and for y. That's the only reason. I could have picked 5, 1. I could have picked negative 5, 4. I could have picked negative 4, negative 3. I can pick any number, but I'm testing this point, which is on this side. I could have tested something on this side of the border. That would have been okay too. But I picked this because it's easy to plug in to this equation. So I'm going to take this equation, y is greater than 1/2 x plus 4, and now I'm going to substitute these values in for x and y. So my y value is 0, my x value is 0, and I'm going to simplify. 1/2 times 0 is 0. 0 plus 4 is 4. Now I ask myself the question, is this a true statement or a false statement? Is 0 greater than 4? No, it's not. This is false. So that means this point, 0, 0, is false. It is not a solution. So that location, 0, 0, right here, is not a solution. So I would not shade this point, and I would not shade any of the points on this side of the border. So I know that this is the false side, and this is the true side, because if this point is false, all the points on this side of the border are false, and this side is true. So I am going to shade the true side, and this is what shading looks like. And that just means that those are solutions. Okay? So that's how you do that one. Now, we notice a different format. This other format is called standard form. Standard form is ax plus by equals c. And we find the x and the y intercepts by covering up. Remember that when we find the x-intercept, my y value is always going to be 0. And when I find the y-intercept, my coordinate, remember, it's going to be my x value, and I know that my x-intercept is going to have some x value, and my y value is going to be 0. And that goes the reverse for the y-intercept. When I look for the y-intercept, I know my x value is going to be 0, and I'm going to get some y value. So x always equals 0 when you're looking for the y-intercept. So I'm looking for this value. That's what I'm doing by plugging in 0 for y. So we have this equation, 5x plus 4y is less than or equal to 20. If I substitute 0 in for y, notice what happens to this term. It goes away, and it becomes 0. So 5x plus 0 is 5x. So notice, this is why I call it the cover-up method, is because you'll notice that it goes away. That when I find that, if I want to find the x-intercept, plugging in 0 for y just leaves me with 5x is less than or equal to 20. So I don't have to plug in the 0. I know all of this stuff already is going to eliminate this term. When I find the x-intercept, I know the other term is going to go away, so I can go straight to this line down here. I can go straight to this and then solve it. So, whoa. So we'll keep this here for the time being. So I'm not done when it says 5x is less than or equal to 20. I still got to solve it. I still have to isolate x. So I will divide by 5 and I get x technically equals 4 because this is my x-intercept. So the inequality is arbitrary. It's not really that important. You can write equal because we're talking about the border. So my x-intercept is 4. So if I went back up here, I could replace the x with 4 because I know that I plugged in the 0 value, and when I plugged in 0, I got 4. So I know my x-intercept is going to be 4. I look, it's equal to, so I know I'm going to have a closed circle. And now I'm going to do the same thing. So I would write 5x plus 4y is, we'll say, equal to 20. And since I'm finding the x-intercept, I'm going to plug in a 0 for x. And what's going to happen to that? Well, it's going to go away. So remember, I can automatically go straight to 4y is equal to 20. Divide by 4, divide by 4. My y-intercept equals 5. So my y-intercept is 5. That would go in for the y value because I plugged in 0 for x. So what value is y when x is 0? Well, the y value is 5. So there is my y-intercept. So I go on the y-axis, I go to 5. I've got my 2 points. So very, very efficient, very easy. You don't have to do this row. You don't have to do that part. We can just cover it up because we know what happens when you plug in 0. It removes the term. It eliminates the term in that expression. So there are my 2 intercepts. I can connect the dots. It's going to be a solid line, remember, because it's equal to. I connect them, I put some arrows on it. Those are the 2 points I would expect to see when given in standard form. And now I'm going to test. I'm going to pick a point to test. Since this line does not go through 0, 0, I'm going to test 0, 0. I'm going to plug in 0 for x. I'm going to plug in 0 for y. And now I'm going to evaluate the statement. And 5 times 0 is 0, 4 times 0 is 0, 0 plus 0 is 0. Is 0 less than or equal to 20? Why, yes it is. So this point right here is a solution. That location 0, 0 is right here, and it's a solution. So I know that all the points on this side of the border are going to be considered solutions. There you go. That's how easy it is. Here is the complex one. Much like I don't want you, do not convert to y equals mx plus b. Do not turn it into slope-intercept form. It's just, it's silly. It's too much work. You have 2 points provided you. Embrace that it's in standard form and how easy it is to find the x and the y intercepts. It is so easy with the cover-up method. Now, notice this one, when we cover up, if we cover this up, let's cover it up. If we want to find the x-intercept, we're going to cover up the y value. We divide by 5. Divide by 5, divide by 5. My x-intercept is going to equal 0. And now if we want to find the y-intercept, we cover up the x term and we divide by -2. And we get my y-intercept is also 0. Ha! Do you know why that's not a good thing? Because if we plot on the x-axis 0, and there's no equal sign, so it's going to be an open circle on the x-axis, and then when we go to the y-intercept on the y-axis, It's the same point. I only have 1 point. Yikes. I only have 1 point, and I can't graph a line with only 1 point. So this situation is the only time that we would change it into slope-intercept point, slope-intercept form. So this, that's how you spell this. This is one of the few situations where you change the linear format. Okay, so we're going to change the linear format. We're going to change it from standard form to slope-intercept form. So we're going to isolate y. So the first thing I'm going to do is I'm going to move my x value and its coefficient. So what gets rid of a positive 5x is a negative 5x. These cancel, and you're left with negative 2y is less than negative 5x. I don't have to put plus 0. I don't have to plus 0. I know that negative 5x plus 0 is negative 5x. Now I have to isolate my y. I'm going to divide by negative 2, and I get y. Now, because I divided by a negative number with an inequality, I divided both sides by a negative number, I need to flip the inequality sign. And then negative 5x over negative 2 is 5 halves x. The two negatives cancel, and we're left with this. This is my linear inequality. So it's in slope-intercept form now. So I know my y-intercept is 0 because there's nothing being added to it. And I know my slope is 5 over 2, and that's why I'm doing this. This allows me to plot my second point. That's the only reason I did that. My slope is 5 over 2. That means I'm going to go up 5, right 2. So from this point, from my point, my intercepts, these are my intercepts. That's why I have this point right here. I'm going to go up 5 and right 2. And then I'm going to do a dotted line. Now, this is my border. My border is false. They are not solutions on the border, and I have to test a point. Typically, I've tested 0, 0, but I can't test 0, 0 because 0, 0 is already used. I know that it's false. I need a point somewhere else, either in this area, over here, or down over here. So I got to pick another point. So I'm going to test, I'm going to test, what am I going to test? I'm going to test this point. I'm going to test the point 4, 0. It's nowhere near the line, 4, 0. Now, I can use this equation, or I can use this equation. I would not choose to use this because what if I made a mistake? This might be wrong if I made a mistake when I was isolating the variable. This one I know is 100% correct because that's the one given to me. So I'm going to test using this. I'm going to use this one to be safe. So I have 5x minus 2y is less than 0. I'm going to plug in 0, I'm going to plug in 4 for x minus 2. I'm going to plug in 0 for y, and I'm going to simplify. 20 minus 0 is 20 less than 0. No, 20 is not less than 0. That is a false statement. So this point is false. This point is false. and I know that it's not a solution. So where's that location? That location was right here. So this is the false side. So if this is the false side of the border, then I know the true side is going to be the other side. So I'm going to shade up to the left. And we're done. So this is the tricky one. This is a tricky one because my C value is equal to 0. That's why this problem is challenging. So we can't keep it in standard form because I can only get 1 point. They have the same location. The x-intercept and the y-intercept are the same location. So hopefully you grasp that. That's going to be a very, very familiar situation. Teachers' assessments will be constantly giving you that dilemma. All right, now we move into 2 equations. We have 2 equations, 2 lines that have solutions, and we're going to do them separately. We're going to do the same thing we did for 1, 2, and 3 for this problem, and then we're going to repeat the process with this inequality. So let's first start with equation 1. Equation number 1, we will say x plus y is less than -1. We know that it's in standard form. So we will use the cover-up method. We will cover up the y value and we will see what it provides us, what it says our intercept is. So if I cover up the y value, I'm left with x and -1. X is isolated, so I know my x-intercept equals -1. And then I can cover up the x value, and y is isolated, so I know my y-intercept is also -1. Now, different from them both being 0, we'll save this for a little bit, these are 2 different locations. Where 0 was the same location when it was x and y, this is a little bit different. So we'll do this in blue. So my x-intercept is -1. I go on the x-axis. Notice it doesn't have an equal sign. So I'm going to do an open circle there. So I have an open circle on the x-axis at -1. And then my y-intercept is -1. So I write an open circle there. I'm going to connect the dots and make dotted lines. And now, much like before, I'm going to test a point. I'm going to test 0, 0 because it's not on this line. And I plug in 0 plus 0 less than -1. Is 0 less than -1? No, that's false. So the point 0, 0 is false, so that means the true side would be on the other side of this border. Okay, and now I'm going to do equation number 2. I'm going to do the same thing, number 2. Equation number 2 is x minus y is greater than or equal to 3. That's in standard form also. Standard form, I know I'm going to find the intercepts and I'm going to use the cover up method. So I'm going to cover up my y and it says x is equal to 3. So my x-intercept is equal to 3. I'm going to move it over. Well, I'm going to move my cover up over. And now I have a negative, so I still have to isolate y. It's not isolated yet. I'm going to divide by -1. And that would give me y equals -3. So I know my y-intercept is equal to -3. That's a little tricky right there. So you got to be really aware of what you need to do in order to isolate the variable. So those are my 2 points. So I look, it's equal to, so I'm going to close those circles. X is 3, so I go 3 on the x and -3 on the y-intercept. That's here, and then I'm going to connect the dots and I'm going to test. Since this line doesn't go through 0, 0, I can test the same location. It doesn't matter You can test different locations. I'm going to plug in 0 for x, 0 for y. Is 0 greater than or equal to 3? No, that's false. So to this green line, this is false. So all the points on that side of the green border is false. So I need to go to the other side to shade the true. Now what I'm looking for is where do my trues, where does the shading overlap? It overlaps in this area. These are the solutions because it's true for green and it's true for blue. So that's how you would graph this system of inequalities. Let's do equation number 1. So equation number 1 is in slope-intercept form. Slope-intercept, so I'm going to find the slope and the y-intercept. So I'm going to look at the y-intercept first. That's -1. My slope is also -1, which is equal to -1/1, because I have to do rise over run. It is equal to, so I can do a closed dot at -1, and then I'm going to go down 1, right 1. -1 is down, +1 is right. So I go down 1, right 1. And I can go down 1, right 1 again, and I have my equation. I'm going to test the point 0, 0. I'm going to plug that in for the y. I'm going to plug it in for the x, and I'm going to simplify. Is 0 less than or equal to -1? That is false. So I'm going to shade the other side of the border because the 0, 0 location was false. Now let's look at equation number 2. Equation number 2 is also in slope-intercept form. And that equation is y is greater than 1/3 x plus 3, 1/3 x plus 3. My y-intercept is equal to 3, and my slope is equal to 1/3. So that means I'm going up 1, right 3 from my y-intercept. My y-intercept is 3. I'm going to go up 1, right 3. And here's the good one. I can also go down 1, left 3. The opposite of up is down. The opposite of right is left. And I can connect. Oh, I just took a peek. I see that those are open circles. So I got to go back and fix all of that. Those were incorrect. So it has to be open circle, up 1, right 3, down 1, left 3, and it has to be dotted. So as I go, I'm constantly checking myself, checking to see, did I do it correctly? Am I doing it properly? I'm going to test the point 0, 0, 0 greater than 1/3 times 0 plus 3. Is 0 greater than 0 plus 3? Is 0 greater than 3? No, that's false also. So from the blue, the position 0, 0 here is false. So this side is false. So I need to shade up to show where the solutions are located. Okay, now where do they both overlap? Where is it blue and green? So blue and green is actually in this area. So that would be my shading for number 5. All right, last one, also still in slope-intercept form, equation number 1. I have a y-intercept of 2 and a slope of -1, which is -1/1, which is down 1, right 1. So I'm going to make it, let's make this in blue. Y-intercept of 2, open circle. I'm going to go down 1, right 1, dotted. I'm going to test 0, 0. So I get 0 greater than -0 plus 2 is 0 greater than 2. that's false. So I'm going to shade away from that point. Point 2, my y-intercept is -2. My slope is again -1. So my y-intercept, it's equal to, so I'm going to do a closed dot. I'm going to down one, right one, and I'm going to do my line. I'm going to test the point 0, 0, and is 0 less than or equal to -0 minus 2? Is 0 less than or equal to? That's false. 0 is not less than -2. So I'm going to shade away from 0, 0 in perspective to the green line. So it looks like that. Do they overlap? Is there an area where there is green and blue? No. So you must write no solution. You must write when it is no solution. You must write. You must write it. Okay? Awesome. Those are 6 really good examples. Hopefully this helps you. Make sure that you're working on Skills Trainer. Make sure you're doing the extra practice. Make sure you're looking at all the situations, just not the easy situations. Make sure you are you completely understand this. There are going to be situations where they don't intersect and all those types. So familiarize yourself over more than 100%. Good luck.